1 second.
I'm chuckling silently.
All right. Hey, folks. Welcome to September 24th's community call. As you can tell, I am not Brooks. Brooks is on an amazing vacation, and I think I just hope that he eats lots and lots of sushi and ramen where he's at. I'm very jealous. But he did get to say hi to Victor. We saw a picture of that earlier, so that was kind of awesome. We've got a packed agenda today. I'm going to do some of the, and yeah, Liam says hi, Brooks, just so you know. I'm gonna run through a couple of things that we've been landing, things that are in progress, and then I think the bulk of the discussion will be around a Kubernetes-native operator that Lucas is going to go through that he created. So first thing first, I just want to call out that we've been landing a ton of things for Wash here lately. So let me pull this up. If you're not aware, we've been working on basically the next version of wasmCloud. And a lot of that is landing in this repository, wasmCloud Wash. So it's out of tree from wasmCloud main. It makes it easier for us to keep main stable, iterate on top of that while we make breaking changes over here. This is starting to really shape up. However, this is a call to action for anybody that's interested in getting started with the next version because we have a ton of issues that are worth running through. Notice that several of these are features. These are features that we need to have before we can actually, cut our next major version. And many of these are labeled good first issues, and they have great detail. Some of these, I think, would be pretty fun for somebody to get started if they really want to get their hands dirty with using Wasm tools, which is the crate that both Wasmtime uses, and basically every language producer toolchain in the ecosystem. This feature I'm calling out directly because I really need it, and I'm going to show you why when I talk through some of the changes that I've been making for setup wash action. But there's a handful of these types of features that are in progress, and we really want, but we don't have just yet. If you don't see an assignee and you want to do it, you can assign yourself or say, hey, add a comment and say, oh, cool if I take this one. And then that counts as a lock on that issue, and we'll look to you to solve the problem. So this is one of them that I call out. There's actually a handful of others that I put in the community agenda that I think are pretty interesting. This one in particular, the way that it would work is that when you build with Cargo Component, or you build with a handful of the other Bytecode Alliance tools for producing a .wasm artifact, we've actually come up with a convention that most of the tools are supposed to follow, which is effectively in the custom metadata section, we expose things like what you would normally see in OCI labels. So you would be able to see the version of the artifact that was produced, what license it's under, where the source repository, where it came from, things like that. And when you put these types of annotations on an artifact that you produce, the key benefit that you get out of it is if you go to, I'm going to show you an example artifact that has these set on it. I know it exists because I added them. So these are the WASI artifacts. And while they were not published from this specific repo, I'm able to actually reference it to this top level WASI repo by setting those labels directly on it. And if you look somewhere in here, I'm able to actually learn more about the annotations that were set. But tools like GitHub packages look at those specific labels, and then they do a lot of nice integrations around it. So it's a really nice thing to have, but also makes it easy for downstream consumers to know what you're going to get out of it. So that's the first one I wanted to call out. Another one that I think is a low-hanging fruit that would be a good one for anybody that wants to get started using even just Rust, is that there is basically a flag that we can pass in on clap. Clap is the crate that we use to do a lot of the ways that we parse in our command inputs. This one would allow me to do things like wash build -- release. So obviously something we really want and need before we cut our major version. And it's also should be pretty straightforward to add, and you can get an initial contribution to wash right out of the gate. Going back over to some of the others that I called out. finding the intended WIT world. What this one essentially means, and I'm sorry if it seems like I'm just like calling out all the things that is my wish list, because it very much is. I wanted to talk about this one on the call just to give a little bit extra context, because Brookspot, aka Brooks, trying out some Claude code integrations, asked a bot to try and take a swing at it. It got a little lost in the weeds. So even though you see a PR for some of these, it's actually not. It's not the case that Brooks or I invested time in trying to solve it. We wanted to see what a bot might do. Bot didn't quite land this one, but maybe a human directing the bot would easily be able to get it done. Essentially, I went through and ran wash build in our examples for Go, and in all of those cases, and honestly, in the most common case for just about any WebAssembly component project, you want to be able to just have one single world that says exactly what it imports and exports. And so when we build it, we should be able to derive, oh, yeah, there's only one world. Obviously, that's the right world. The reason why it matters more for Go than other languages is that Go is one of those that doesn't have like a top level SDK type experience like you get sort of with TypeScript, where I can pass in extra information on a package.json. There's not so much as a thing. There's Go mod, but it's not quite there, and I can't like add stuff into the Go mod that says this is my WIT world. So putting the smarts in Wash would give us the ability to simplify the experience without having to have a config file. Just the key design goal that we're aiming for with Wash is that it's a polyglot build tool that you can use across any WebAssembly project, and it just works by default. It does the right things by default. And the right thing in any WebAssembly component project is if I only have one world, that's obviously the one that I'm targeting. So that's essentially what this one is. And last, but certainly not least, is adding a little bit, and this one's a little bit older. I didn't need it until very recently. But essentially, we output what the artifact path is when we're building a component. And that maybe is helpful, I guess, if you're interacting with the CLI and you built and then you know exactly where the path is and then you can run that. But really where this shines and where it's super key is when you're writing build automation and you're creating a GitHub workflow and you want to take the output from build and immediately pass it to a publish action, which was the use case that I ran into. So again, when I'm building Polyglot, the way that we previously solved this is we said, okay, well, we don't really care what language you're doing. We're going to create a build folder, and then we're going to copy the Wasm into that build folder. And so in the past version of Wash, that's how we worked. We were able to just always assume that there's going to be a builder and then reference that. But that's not idiomatic to a language. It's a little bit intrusive. And our key design with this next version of Wash is not to be intrusive, like not to roll up and be like, okay, you got to create a wasm.cloud.toml. You got to add in all of our specific information to do this thing, because the reality is all that information is already in your package.json, your cargo toml, ideally your Go mod, but not yet. And so by being able to derive based on the language and the project that you're building in, where the artifact went at the end of in the output allows us to basically be able to say, here's your input to a wash build command, here's your output, it's the artifact path. And so when I run something like, let's do wash build, you'll see that we're able to pass an output JSON. So if you're writing build automation, you can say wash build dash output JSON. And actually, I'm not in a let me go to somewhere that I know we can use. Let's do the bytecode alliance sample. I should be able to just build this random project that obviously is in the bytecode alliance, doesn't really know anything about WasmCloud. And I want to be able to say wash build output JSON. And I'm running with my own custom version. I can't believe that worked. Well, what I just got surprised here on the call is I just added another plugin that I thought might be interesting, and I'll talk about that in a second. I wanted to be able to have it where, hey, maybe I could add in extra language features like cargo auditable, and when I'm running in a Rust project specifically and I do a build, I always get an audible artifact at the end of the output. But the thing that I wanted to call out is this little data blob here. This is the thing that we can attach a lot of different interesting outputs for anybody that's trying to create these GitHub workflows. By doing this, we can get GitHub workflows that are also potentially language agnostic and reusable across many different projects. So just to give you a little bit of a taste of that, and just to motivate why basically all four of those issues that I called out are all relevant for specifically this use case. So I've talked before about in wasmCloud us building out a shared monorepo of common composite actions that we maintain, and also submoduling in actions that need to be published to the marketplace. So we have an action already that's published to the marketplace. It's got a couple new enhancements that have been coming in. I think the biggest one is that we now have the ability to pass in plugins, a plugin list to the setup wash action. I still have that ready to merge. I haven't technically merged and released that one yet, but the idea is that, let me actually just pull up that PR real quick, just so you can see. Setup wash action. And here we've got a PR up for being able to enumerate your plugins. And then I also made sure that I added those as well to the cache so that if you kept rerunning this, we weren't always re-downloading the same set of plugins. So you're able to just pass in a list of your plugins. I want to land this with an example plugin. I was thinking cargo audible, as you can probably tell from my build. Okay, so I just gave you the list of those actions, and now let me show you where and how we would apply them. So this is specifically taking that setup wash action and then creating another composite action on top of that. This composite action is just wash build. So I just go and say, hey, run wash build, take that output that I was talking about before and parse that data blob and get the artifact path. When I have this artifact path, now I have a build output. This is a composite action that I could drop into any WebAssembly project anywhere. And now it just knows how to build and will give me the information that I need for the next step in a given workflow. That might be go run some type of validation security run against it. Or in my case, I was actually working on, sorry for all the red squiggly lines, I'm refactoring, but essentially running that exact same composite and then immediately doing another thing that would also be portable across all projects, totally agnostic to what language it was written in, which is being able to take that component, run wash OCI push to push it to a registry, and then at the end, do attestations on top of it. And notice that all of these just build on top of being able to take that previous output from a GitHub workflow, using those outputs and then applying them downstream. So in this case, being able to just take the digest out of what we build. And that was one of the other fixes that we landed this week, was making sure that the things that any GitHub workflow or any other build automation would want to build on top, it includes that in that data blob. So digest is one of those that we just added as part of a wash OCI push. So that was the whirlwind tour on updates on setup wash and also just on the wash project in general. So now I am going to stop because this was, hey, we all love CI automation stuff, right? Maybe. I think probably some people took a snooze, and that is a-okay. Because I've given enough time for anybody who wanted to join but was joining late to now check out the primetime part of this show, which is our new runtime operator we've been working on. Lucas, would you like to tell us what that is and why people should care?
Thank you, Bailey. Yes, so let's get on that. I'm going to share my screen here. And hopefully everybody can see me fine.
Yeah,
I cannot see anybody right now.
It looks good. Classic
looks
quote
great.
here.
Looks great, Lucas.
I just found the video. All right, so what I'm going to talk here about is the transition between going from the Kubernetes story in WasmCloud v1 and the Kubernetes story in WasmCloud v2. And there's going to be a lot of YAML ahead. So get ready. In terms of architecture, one of the key changes here is that we are no longer deploying WASM or NATs. So before, what the wasmCloud operator was doing is it was being a reflection of the data that we had in WASM. So it was passing data between the Kubernetes API and WASM, but it was not actually participating in scheduling decisions or anything. So what this means is all the state for the workloads was still living inside WASM and NATs. If the operator went down, system would continue to work. But if NATs went down, we would have to recover the all the deployments, all the manifests from somewhere else because it's not coming from Kubernetes. With what we're doing now with the runtime operator v2 is that we are no longer deploying with them or NATs, and all the state is being stored in Kubernetes together with the CRD definition. So the operator becomes a bit more stateless with this approach. And there's also no need to worry about, well, should I back up my NATs? Do I need a 3-node cluster or not? And I'll go a bit more into the NATs story here too. But the TLDR is now the installation footprint is smaller. And what we're also doing here is a bit of alignment with the Kubernetes proper. So the concepts that you have in Kubernetes and also the concepts that we have in wasmCloud when scheduling workloads. So if you're coming from Kubernetes, you understand that a pod is a set of containers bound to a given host. So in wasmCloud, what we're doing is aligning the naming there, and we have a CRD called workload, which represents a group of components deployed on a single host. On top of that, we have the replica set concept, which in Kubernetes manages the number of pods, replica count. And for Wasm Cloud, we have the workload replica set managing the replica count for workloads. On top of those two, we have deployments. And Kubernetes also has daemon sets, like stateful sets and so on. But for Wasm Cloud right now, we have only deployments. And at that layer, we're managing replica sets. So if we were to kind of get a bit more real about what they're really doing, the replica set ensures that a certain number of pods or workloads are always available, are always there. So they have to be placed. What deployments are doing is it's determining if you want to issue a rolling deploy, if you want to do a blue-green deploy, a canary deploy. So it's controlling a few different replica sets underneath and orchestrating them to have zero downtime deployments. But with all of this is we now have more flexibility. But if you're coming from Modem, you're probably looking at workload deployment as your go-to YAML of preference. And talking about like the comparison of how things were done before, how things are done now. So on the left, we have WASM manifest. And on the right, we have the runtime workload manifest. So right from the first impression here, there is less YAML, and less YAML is good YAML. One of the key differences, I'm gonna talk about them a bit more in the future, but at this point here, the key thing to keep in mind is we are going from a concept where you could declare components that have unresolvable interfaces. For example, you can deploy an HTTP component without a provider that backs up that HTTP interface. So that was something possible with them. Now, within a workload, all the interfaces are expected to be resolved. So they have to be either coming from another component declared in the workload or from the host. So this is it was the expectation with wasmCloud v1 that we would always have the full world resolution present in the YAML. But if you made a mistake and you forgot a provider, the system would still accept your application and it would turn into an outage. So because there was pretty much no checks at all on if all the interfaces could be fulfilled within a component space. So now we are bundling that all into a workload concept. And a workload is you have a set of interfaces that you need, and you have a set of interfaces that you're providing. That that Venn diagram should be a circle. So the other thing that is interesting here is we're going from application, which we used to declare how that application will be scheduled. And in here in the workload, we are not seeing a replica count. But if we remember what we're talking about here, the workload is at this layer. There should be no such thing as replica count here. That's when we look at the workload replica set and workload deployment. For all intents and purposes, they are exactly like a workload here inside this template field, which looks a lot like the deployment template field in Kubernetes. And for the workload replica set, the extra field that this is adding is replicas. With this, what you're saying is, I want that workload replicated to 2 hosts, essentially. The deployment goes above that, and now you can say, I want replicas too, but anytime I change an image or any setting inside this spec, I want you to deploy a new deploy a new host, and then take out one host and do that in a controlled way. So it's essentially creating a new replica set with the new configuration, setting that replica count to 0, then setting it to 1, to 2, to 3, and managing like the previous deployment and the next deployment all at once. So it's the orchestration layer. Now, uh, a few key differences here as well, which I think is worth calling out. In white, we are going from the OEM specification, which I'm not exactly sure what state it is these days, but we're going from that specification over to a wasmCloud specific uh, specification. So these are CRDs that are fully under wasmCloud's control. So we don't need to be relying a lot on specific key value pairs of strings and having to enforce typing ourselves. So now we can create proper fields for the things we need under the scheduling layer. So the white boxes here are about the OEM spec. The red ones, the red box here on components, this might not even be that well known, but with them, the list of components that you're adding in here, it's not guaranteed that they will be placed on the exact same host. So you might deploy an application to a DEM, listing your components and seeing higher than usage latency, and you don't understand why. So that's because your component is going to NATS, making a little round trip, taking the scenic route, and then back to the exact same route, the exact same host. So really doesn't matter because it's a limitation of the system, the scheduling system there. For the new specification, what we're doing is everything that you declare in a workload is guaranteed to be deployed at the exact same host. In fact, they get the identity for this workload is at the workload level, and then we have individual identities for each component, just like Kubernetes and containers. The third box here, the green one, has to do uh, with providers, with the interfaces that are not coming from any component. With them, we had the concept of external providers, and you would declare them here in your configuration. the wasmCloud host downloads this binary on the spot and executes it on the host. You can imagine the security challenge that this poses. And for the new model, what we have is in-process plugins. So these are plugins that are written in Rust. They are part of the binary that ships with the host, and they pretty much are part of the host. So they have the same facilities, access to the same environment as the rest of the Wasm Cloud host. And in here, in the same way that before we had to specify a bit of configuration, interface links, and so on, that has been comprised and made a little bit more user-friendly here in terms of how we specify it, the names, the types. So in this case here, we have an HTTP provider and we want to bind it to a component. So we created the component, we created the provider, and then we go on the provider and we link the provider to the component. So instead of the component being the one saying, hey, I need HTTP and I need this address, we have it wired kind of backwards that the HTTP server needs to know all the components that it will talk to. It gets a bit more complex when you start thinking about shared providers, but this has now been replaced with this in-process host plugins, which they are shared by nature. So the same instance of a given plugin is shared with all workloads, but each workload has their own context, their own like boundary for data access. The other key thing here is because now components are all placed together on the same host, if you have a NATS outage, we are not impacting existing workloads. We're only impacting the scheduling part of the system. So, and going a bit beyond the basics here, like just doing the give me an HTTP component, we have the ability to target hosts by label. This is something we also had back in with them, but now we also have the option to force schedule a workload on a given host ID. So the host ID now is simply a UID v4, and I'll show that in a minute in the little demo. But once you have that host ID, you can staple that into your workload definition, and that forces that workload to always be placed there. We also have the ability now to export volumes to components. And this part here is pretty interesting because we can expose an empty directory, or we can expose a host in the path. And just like Kubernetes, we declare the list of volumes we want to expose to the workload here. And then each component in the workload can claim a given path to that name. And these paths can be different on each component. The host interfaces, so this is optional, is only in case you need some extra interfaces from the host. This is where you would add them. In the example I had before, I did not have version, and this is because the host will try to find the best version for that match. If the workload requires a specific version of a given WASI interface, it can lock it here. So this becomes one of those situations where you wrote something for blob store 020, but 022 is coming out. So this allows you to be really specific about your requirements. Liam, I see you have your hand up. Anything?
I was going to let you know that there are a couple questions in chat here.
Oh, okay.
Um, Frank Shaffa wants to know, since we're doing it with the / with Kubernetes, is affinity or anti-infinity being considered?
Yes. So the concept of affinity, anti-affinity, this will be part of the replica set, the deployment controller. Yes. And let me actually go through a few
Actually,
here.
Lucas, one question for you real quick. I just want to understand, so that when you have like a host interface that's asking for something specific, does that basically and with like the host selector requirement when it's making a scheduling decision? So like if a certain is that the what it works as? Okay, I just wanted to check that that
Correct.
was right.
Yeah.
Okay.
I'll do a little detour on that one because I think it might be interesting to see that in action. So just subscribing here on a health check, and this we have here on the health check from the host. The host actually now tells the scheduler, like, I have all these plugins available to for scheduling, and then the operator uses that information to find the correct one. Mm, OEM, yes. Cool. So I'll continue on here, and now I have the chat on watch. Uh,
Hey, Lucas, I have a point question for where I think a point you're about to make. Is it possible for components to share the same directory in a volume mount? So I have one workload and two components that want to work on the same file.
Yes. So if you, and these can be either a host path or an empty directory. So you can think of a situation here that you have one component being the worker, one component being the producer. So you can request an empty directory and use it in that for message passing, pretty much. Right. I'll keep moving on here. Uh, so version locking, pretty important. Now we have it. The The host interfaces, they have an optional configuration. So it might be that WASI HTTP accepts a host that letting you declare which host you want that component to respond to. This might be blob store, messaging, where you pass which topic you want to subscribe to, things like that. Uh, but notice here that the binding saying I'm I'm a component and I need to serve HTTP for host example. This information is now part of the workload. It's not a provider link that is kind of external to the view of the component, the ownership of the component. We also have here image pool secrets, and this I think it's one that has been requested quite significantly on the V1 version. When we are fetching component images, we can now specify a regular Kubernetes secret, which is going to be used as registry credential. We can define here a pool size, which is essentially saying I want to have 5 instances ready to go, and if you go above that, you start spinning them up in as you need. So you can think that if you want to deal with bursts, especially if you have some sort of flash sale where you're expecting to receive 1,000 requests, but they all happen at midnight because that's when the sale starts. This is the type of feature that is interesting because you don't need to rely on the system, on the ability of the system to get all those instances on demand. You have that memory ready to go, and then this way you spend less time in cold starts. The pool size works together with max invocations because one is telling you the limit, and the other one is telling you how many to keep warm, essentially. And for max invocations, what happens is that the component will pretty much not respond to that request. There will be a queue. So it's not that we are emitting a trap or failing once we reach to that limit. We're essentially applying pressure, and 100 here is essentially how many items I want to apply pressure on. Local resources has to do with information that is going to be local to this given component here. So as components now are a list, well, they were a list before, but because they are a list, we might have volume mounts that are applied to this component, but not to a sibling component. And this is also valid for configuration. You might have configuration that should be visible to one component, but not to another one. So this allows us to separate here the configuration and also to say things like fetch my configuration from a config map or from a Kubernetes secret, or here's the configuration in literals. And this way we also we overlay that configuration. So we start with the secrets, we go to config, and then we go to the literals. And the last one here is one that is pretty fun as well. We have the concept of allowed hosts. And what allowed hosts is controlling is which HTTP outbound hosts is this component allowed to call out. So if you're deploying a group of 4 components and only one of them is supposed to be doing HTTP calls, that's the one you introduce the concept of allow hosts there. By default, all hosts are allowed. So if you want to deny, we're thinking here with the idea of introducing a deny hosts instead of allow hosts. So something that will probably change. But the LDR is because we have access to the host name components are connecting to, we'll now also enforce policies on that. And let me just show things around here for a quick second. Great question. So Frank is asking here if their capabilities equivalent of network policies to control who can talk to who. So workloads, they only talk within their little bubble. If they want to talk to another workload, they have to go through the Kubernetes networking pretty much. So what this means is in the next iteration here, we're looking to give each workload their own IP address, essentially. So in a way that they are addressable directly from Kubernetes. And that's why the control that we're starting right now is the one that is on top of an existing WASI interface. It's not on top of TCP/IP, and it's also an outbound interface because we realize the inbound interface is way more complicated to implement. And where was I? Here. So I have the operator installed here. I have a host, and saw 2 seconds ago the host sending its heartbeats every now and then. In terms of information coming on the heartbeats, I think it's also worth call out here that we're now including a bit more information in terms of the system itself. So we get the system CPU, we get the memory, and we also get all the interfaces that are being exported by the host. And this is via its host plugins. We have key value blob store, config, and HTTP. We get now a list of hosts, all the hosts that are coming up inside the Kubernetes cluster will register with the operator. And at the moment that they register, they will start reporting here as a regular CRD. And you can think of this like instead of having to do wash get inventory and check the status of your host, you can do kube get hosts. And this tells you if they are reporting, if they're failing, they will fail. They will be marked as not reporting if they have not communicated back with the backplane up to 2 health checks. So this is the list of hosts is also managed by the operator. So this is not something that users are expected to come in here and create. The next one here is the workloads deployments. So I have one here, which is a HTTP workload. And is it up? Yes, it's up. What I'm going to do is I'm going to describe it just so we see what's in there. And as we can see, we have the deploy policy. This is a rolling update. We have here also the specification saying this is coming from a component image from Hello World Rust. In the status, and this I think is where the fun is, we know that this artifact was fetched correctly. We know that this workload is in sync with the host. So the last time that we went to the host and asked about this workload, it was there, it was running, it has been deployed, and it is available. So the scalability, the number of replicas that we requested is the same number of replicas that we see in the system. And in general, this workload deployment is ready. We also have some information here, more like bookkeeping, which replica set we are deploying, how many of them are ready, how many of them are still coming up. But as we talked before, the workload deployment creates a workload replica set. And from here, we're going to have something quite similar, a bit smaller, but we're still reporting here the number of current replicas they were expecting and so on. Now, from the workload replica, we have the actual workload. And when we get to the workload level, we now see exactly which host ID that workload is running. And you can imagine this a bit similar to doing like you're going to kube system and asking for dash dash white or something like that. Yeah, there's an extra switch here that also includes the host name. So that's kind of what we're going for. So with the workload, you know exactly where this workload is being placed in terms of hosts. Why is this important? Because this is going to be the identifier that will be present in log, in traces, in metrics. So this together with any information that is available as an annotation here. So we know that this here is coming from a replica set X, and actually this one here. And the information in here has to do with the communication between the operator and the host. So which host did the operator talk to, and what identifier did the host gave this workload? So that, in terms of looking at from the outside, that's essentially it. And let me do API resources runtime wasmCloud here, because then we can see what is coming down the pipeline. So we have artifacts, which I did not talk about, but artifacts are essentially a way to have an artifact pipeline in your deployments, so you can run adaptations like WAC. We have the hosts, then the deployments, replica sets, and workloads. Back here, where is this going to land? So this will be in wasmCloud Runtime Operator. And if you want to take a look at it right now, you can go check Cosmonic Labs Runtime Operator. When should this start landing inside wasmCloud Runtime Operator? It's going to be together with the host v2, the runtime v2, which is the work that Bailey was talking about before. So I talked a lot. I'll stop here, see if there's any questions.
This is awesome, Lucas. Thank you for the walkthrough. I dropped some links earlier, one being an implementation of the workload API. And Brooks gave a similar presentation last week going through the architecture of how that API works and how we'll build a host around that for V2. I talked a little bit about WASI P3, which is designed around basically this whole entire evolution, both with this workload API, but making everything pluggable. And then obviously for deployment side of the web and take it all the way to prod, you needed a good deployment story, which this runtime operator, I believe, really fills that goal. So I'm pretty excited, and we've been dogfooding it for a bit in our own deployments, and it's real nice, y'all. Like we've got rolling updates, we've got being able to control things versioned, we're deploying via Backstage and Argo CD. So we're able to do GitOps against all of this. It's been a huge improvement over what we had in V1. So we've learned so much over the past year running on top of wasmCloud V1. And I think we're ready for feedback. So folks that are doing this, let us know if we have solved all your problems, or perhaps more likely, what problems remain.
So one thing, I mean, I think this is really great and great presentation also, Lucas. So if I want to play with this at home, is there also documentation with this? So I can try to do this on my own.
Not right now. And why we don't have anything right now? Because we have the operator in the public, we have the runtime being developed, and then we have the mock host on my computer and Brooks's computer. So what we're looking at here is to make sure that these things are not simply dumped there. So we are looking to have this as a single drop. We have the runtime, the host, and the operator going to wasmCloud. But in the meantime, we are doing all the development in the public. So you can go to Wash and see the new runtime. You can go to Cosmonic Labs and see the new operator.
Yeah, I guess we don't like to point folks in the WasmCloud call to what we're doing over on the commercial side of things. But Frank, I know that you've been engaged with us there before, so I'm okay to say if you try our trial, that deploys basically with a version of this operator where we've embedded it inside our product.
Yeah, I'm making a difference. I mean, what I try here and what I try at home, right?
Yeah.
But
Yeah.
thanks.
We've been trying to move this along, really quickly, co-building it with a number of folks and getting feedback. And so we, have been kind of like iterating on the interface. I think the plan is to get actually an updated release out, in the next couple days, Friday or Monday or something like that. That will have land some improvements here in the design compared to what I think is available right now. But that is in the public and the repos that were linked there, so you can go and see what how we've been thinking about this. And I think it is a lot more elegant, from a deployment perspective and especially from an integration perspective. One of the big things is that it really enables you to leverage the entire Kubernetes ecosystem out of the box. And that's been the biggest advantage is all of the integrations that you have. Now, there's a nuance there in that, and Bailey said this in the chat, in that the wasmCloud host is running in a container. So all of your containerized controls work here. And then for each component that we have running on top of it, there is, say, differential support for the entire pipeline. So, for example, things like signing a component work just fine. And there's a new blog post that we put up a couple weeks ago that document that on the webpage. However, we're still dialing in the per component IP controls. So you could control on a per basis which component can talk to which. Think about if you saw the Microsoft was that post. Taylor, I think you were working a little bit on that with the team over there. That would be the kind of feature that we'll work on getting in next. And if folks have ideas or requirements or requests, we'd love to hear them. I apologize. My face is swelling. I think I'm allergic to apples all of a sudden. I was eating an apple off the call, and now my face is all red, and apples are spicy. I don't think they're supposed to be spicy. Sorry.
Oh no.
Bad apple.
Go get that Benadryl. And also maybe 99.
See my face swelling as I'm looking at myself on the call, though. Sorry.
Yeah. So essentially, Frank, I'll drop some steps. I think we've got a Cosmonic channel in our Slack, so I'll point you there. And then we're basically, as you can tell, there's like 4 key moving parts, and keeping them all in sync and iterating really fast because we're getting a ton of feedback every time we drop a new release. We learn a lot, iterate. Keeping it all online is, it's a thing. That's a lot easier to do when you ship a single package of it. So I'll send you a link to the single package, and then also all the links to where we're doing the different drops in all of these different repos.
Okay, great. Thanks.
Any other questions for Lucas or anything about the operator? Okay. I've got documentation PR of the week. Well, first things first, Eric's PR that we mentioned last week landed. So all the stuff that we're talking about, we have been adding documentation. I think it would be closer to say that we have a placeholder for where we can make sure we get really good documentation before this release right now. And we've been adding it there. So if you go to wasmcloud.com and you go to our docs, you can drop down to next. And next is where we'll be talking. It already has how to install and work with the next version of Wash. Runtime Operator is in the queue. And then also talking about the next host. Anything more you want to say on that front, Eric?
Yeah, just that the latest PR in the docs repo has a breakdown of the proposed outline for a kind of reorganization of the docs moving forward. So if anyone has any thoughts on that outline and wants to put any commentary there, that's very welcome and appreciated. And we'll just continue iterating forward on the pieces of this next release.
Cool. I dropped a link to that in the chat here. To answer the question, is there any doc that was asked earlier? Sort of, not quite, but soon. And that's where to look. Then the other thing on our agenda, just wrapping things up, we tend to try to bring in any community updates we can. Well, I have a pretty freaking cool one, which is Wasmtime cut a release with WASI P3's first RC. So WASI P3, there's an initial version implemented in a runtime near you. And if you think that's exciting, you're welcome to talk to us and we can kind of guide you through it. It's a release candidate that already has outdated interfaces. We've already made updates across all of them. That was expected. We've got a couple more iterations to do on that front. Definitely more iterations to do in terms of language toolchains. So this is very much focused on the host side of this equation. But it's happening. It's getting closer. It's looking real. We're on track for our current roadmap. So I'm pretty pumped about that. But yeah, you're gonna see some pretty big changes in your Wasmtime embedding because we went from async to sync to async, y'all. So yep, that's a change. We only have 2 minutes left, so that I'm not going to go into too much detail on that, but I think just being aware that it's out there and we're obviously aiming to consume and deliver that as part of our next version of our host. We're not probably going to take this RC since we're also the ones that made these changes to the interfaces to fix them upstream. We want our changes that we needed to land, and then we'll integrate those into WasmCloud host, our next version. Anybody else have any highlights, community things, anything you want to share? No? All right. Well, hey.
I would maybe just
yeah.
comment. Jacob's company Betty Blocks put a nice little video into WasmCloud Slack. If you haven't had a chance to check that out, they're doing some cool stuff with Wasm there. I think it was worth a watch with the WebAssembly components, and I think it also ended up out on YouTube as well.
Cool. Yeah. Please hop on our Slack, like, subscribe. All right. Thank you, everybody. I hope you have an awesome Wasm day.